Thank you for being here today. I am Moneeb Genedy, a postdoc at Cornell University. So again, if there's any questions, I will be happy to discuss after the session because I'm just going to be going a little bit quickly through the presentation. So I'm going to present on the development of sustainable polymer modified concrete for 3D printing application. In this presentation, I'm going to go over very quick background, then the material development, our mix design, then the mechanical properties we have for our developed mix, rheological characterization for the 3D printing, and our 3D printing process and the performance of 3D printed concrete. Then going to go for future work and the conclusion. So as everybody here knows that the 3D printing is going, the market of 3D printing is increasing significantly. So in just 2021, we expecting to have $11.3 million market for the 3D printing. And this by 2030, this can go up to $1 billion market. So this is significant increase and going very quickly. For the 3D printing process, there is too many parameters that controls the quality and the ability to print concrete. So the main things what we are focused on this presentation is with typical concrete, we have issues with interlayer bond strengths. For normal concrete, that's a typical issue for 3D printed concrete, that concrete fails in the interlayer bond. And the other thing is the long-term durability. And we believe with the addition of polymer to concrete, we can adjust these two issues we have for 3D printed concrete and improve the performance of 3D printed material. So for this, we use SBR latex as a polymer modifier for our concrete, and we develop 5 mixes with different content of SBR from 5% to 25%, and we use the water to cement ratio of a water to cementitious material ratio of 20% and aggregate maximum nominal size of 2 millimeters. So first, we just for the typical mechanical properties of the concrete developed as expected with addition of the SBR, we see decrease in the compressive strength, but we still with the maximum content we have 25%, we get more than 40 MPa compressive strength, which is very impressive for SBR modified concrete. But on the other side, we see a significant increase with the flexure strength with adding the SBR, and that's expecting because of the ductility of the polymer. It's more flexible, it gives more deflection before cracking, so that's increase the flexural strength of the developed mixes. We're gonna go next how we can adjust the rheological properties of the developed mixes to be able to print with this new concrete. So this is, of course, known for the printing. We need to make sure that we have enough yield stress to able to build on top each layer on top of each layer, and the entropy with time, so we can go as high as we can with the 3D printing process. So with this test, we did a 6-tropy test where we define the yield strength as 6-tropy of each developed material. And with this, we can see is that with the addition of SBR, we start to lose the yield strength, which is limits the printability or the buildability of the material. And also we start to see a loss of the 6-tropy. So with the increase, but the 6-tropy was more sensitive to the SBR content than the yield strength. So we said, with that, can we print with this? So the first thing we did to print is to build our own 3D printer or extruder, and that was done by our brilliant undergrad, Champ. He developed this from scratch. He built it piece by piece. He actually 3D printed all the pieces of the printer and put it together. So this is just a thank you for him for all the effort he did. So started with not a huge printer, but a reasonably sized printer that can print up to 2 feet by 2 feet by 10 feet printing area using auger extrusion, and we can print up to 20 liters of concrete at a time. So this is just champ trying. We'll see putting everything together, and successfully we have our first print earlier this semester with normal concrete with just control mix. So what we did, we can see, can we achieve what we're trying to do with our SBR mix? Can we improve the bond-to-bond layer strength? So we did a short beam test where we have 4 layers printed, and we did a short beam flexure test to see what is the shear strength we have, and we find with SBR mix we have 40% increase of shear strength. But the most important thing is the mode of failure. This is the normal concrete mix. It have clear interlayer failure, while we have a clear shear 45 degrees with the SBR mixes, which is very clear. Now we have improved the bond, the layer-to-layer bond strength, which is one of the goals we have with this mix. The challenge we have is with buildability. As we see from the rheological properties, we have lost some of the yield strength, we have some loss of the sextropy. So we did a single and double wall buildability test. For the single wall, both the control mix and the SBR modified with just this was 15%. We had a collapse after just 6 layers, which is not a great buildability test. This is a challenge. When we go to the 2 double walled layer, we reached the maximum height we can do with the print, still stable for both the control and the SBR. And with this, we have to address the issue we have for our printing process. We are not using any set accelerator. This is because we are doing a batch mix where we have to keep the material flowable for the entire printing time, which is the challenge we have here, and that's what we believe with improving on the future work is our printing process, where we can add set accelerator at the nozzle, or where we can use an inline mixing. This material can actually be a very potential, very good material for 3D printing to overcome the bond-to-bond, the layer bond strength issue. So for conclusion, at the end, again, incorporating the SBR shows some reduction in compressive strength, but increase the flexural strength. The SBR content, the increasing SBR content result in reduction in both yield strength and sextropy, which is affect the printability of the material. But with the right additive, we believe that can be overcome. The SBR concrete, we can print. We will achieve to a printable mix with SBR content, and we were able to overcome the layer-to-layer bond issue that is known for normal concrete for 3D printing. And lastly, that's improving the printability is what we are looking for with appropriate additives and improving the printing process. And just like to thank you and welcome any questions.
Thank you very much. And a special thank you